Dear students, this is the continuation of the previous video. Now, we'll see in this example. Use Prim's algorithm. Determine a minimum spanning tree with minimum total weight. Okay. Already we have seen we have 5 steps to apply Prim's algorithm. Now, we'll apply one by one. What is the first step? Select the edge with the smallest weight. Okay. Now, here, how many vertices? 1, 2, 3, 4, 5, 6 vertices. Okay. And how many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now we have to cover all the vertices, and in the final answer I'm telling, we have to cover all the vertices, and there should not be any circuit, but it should be connected and weight should be minimum. This is the condition to find minimum spanning tree. So first step, you have to see the minimum weighted edge. Okay, 10, 50 something here, 55, 25. Okay, but minimum weighted edge is 10. Okay, now you mark it, and you have to write 3 columns. See, edge and cast and spanning tree. Now here this 10 is the minimum weighted edge among all edges. So now write 10. This is the weight. Here write 10. This edge is nothing but 1, 2. You have to write the vertex. So 1, 2. You have to write the vertices 1, 2. The bracket. This is called edge. Okay, 1, 2. Okay, simply you write 1, 2 or 1, 2 with bracket. Okay, this is the edge. Okay, this is the minimum weighted edge. First you identify. Okay, now after that you graph that edge spanning tree, that is spanning tree, first one. Okay, you can write the weight also here. That is good. You can write the weight also here. Okay, now next what we have to do, see here, find all the edges that connect the tree to new vertices. Find all the edges that connect the tree to new vertices. Now you see here we have these 2 vertices. From here you see how many edges we have that create a tree. 1, 2, 3. Okay, from this vertex we have 3 edges. From this vertex we have 2 edges, total 5. Out of this, which is having minimum weight? Here 50, 40, 25, 45, 30. So now we have 25. This is the minimum weighted edge. So now mark it, write it here, 25. And one more condition. See, first you have to check from 2, 1, 2, 3, and then from 1 to 5. So here this is connected. From this vertex we have edge to 6. So this makes the tree that we have to confirm 1, 2 and 2, 6. That should not create the new edge. Whatever you add, see, this is the already existing spanning tree. You are adding the edge. This should not create a circuit. That is very important. Okay, when you add a new edge, you have to see this. It has to form tree. It should not create a circuit. That is very important. Now, so 25. The name of the edge is 2, 6. Here I'm writing, yes, 2, 6. Here actually you have to write here weights 10. This is 25. Okay. Whenever you add one edge with the existing edge, you have to draw the graph. You have to draw the spanning tree continuously. This is the procedure. Now, next, from here, you see from 6. So, 1, and from 2 also we can see this one, and from, okay, 2 here, this edge and this edge and this edge and this edge. Okay, so many edges we have, but what is the minimum weighted and which is connected with the already existing spanning tree? That is very, very important. Okay, now you see this is 15. This edge, yes, is connected with this vertex 6 because you have already 6 here in the existing spanning tree already. So now this 15 you can take it. This 15 is nothing but the edge is written by 3 6. So 3 6. So now you join this edge. From 6 you write 3. That 6 3 or 3 6 edge. So this is 15. You write the weight also. That is missed here. So you write the weight of the edge. Okay. Now already we have 1 2 6 3. Now again apply the same procedure. Now you see from 6. Now from 6. Now you have so many options. See, from 6 you can see, and from 2 you can see, from 3 you can see, from 1 you can see. So many edges you have. But whenever you select the new edge, first condition should be the minimum weight. Second, it should not create a cycle, and it should be connected. Okay, so now 20. Yes, you can select 20 because this is from 6. So from vertex 6 it is connected with the vertex 4 through this edge with weight 20. So I can select this edge 6 comma 4. I can join here from 6. This is the latest one. This is the latest one. So now actually you write here the weights for all spanning tree. Okay. Now next one. See how many vertices covered. You have to count now. 1 2 3 4 6 5 vertices covered. Actually total vertices are 6. So now which one is missing? 5 is missing. So now to select 5, see, to connect the vertex 5 with the existing spanning tree, which edge you can select, because from 5 you have 35 to connect the vertex 3, you have weight 40 to connect 2, you have weight 45 to connect 1, you have weight 55 to connect 6. But it's very, very important. Now you see 1 and 2 you have to select the minimum weighted. So you can select the weight 35, and you have to see if you select this 35 minimum weight, the edge is 35, this edge is 35. It's not creating a cycle. That is very, very important, not creating a cycle. So now see 3 5 3 5. Actually 2 and 5 is not connected. It is very near, very close each other, but it's not connected by edge. Okay, here no edge. You have to understand, here no edge. Between 2 and 5 no edge, but 3 and 5 is connected with the weight 35, the weight 35. So now this is 35. Yes, this is 35. So now this is a spanning tree, minimum spanning tree we can say. Why? Because we have selected the minimum weights of the edges, minimum weights. So now see here all the vertices connected, and it is a tree, and here no more cycle, and weight is minimum. So what is the total weight? Now you can add all the weights, that is 105. This is the minimum total weighted spanning tree. So this is called minimum spanning tree. That is what we want. So minimum spanning tree. This is the minimum spanning tree. This is the minimum spanning tree. When you write in the exam, you have to write here weights also. Okay, don't forget, write weights also. And this is minimum spanning tree, and this is the weight for the minimum spanning tree, 105. Now you can see another example. This is the method, this is the procedure you have to write. When you write the answer for this question, you create 3 columns. First one for age, second one for cost, third one for spanning tree. Whenever you select the minimum weighted edge, you have to draw here spanning tree. Whenever you take new edge and join with the existing one, you have to draw the spanning tree. It is very, very important. This is the step, this is the procedure how to apply the Prim's algorithm. Okay, we'll see another example. Now You see, use Prim's algorithm, determine a minimum spanning tree with minimum total weight. Now you see here, I have not written the procedure because already we have discussed it in detail in the previous example. Now you see this graph. Now you select the minimum weighted edge first. This is minimum weighted AB. So now I select first AB. Okay. And then from A, you see from A 1, 2, 3, 4, but already we have selected AB. So 1, 2, 3. The weights 10, 23, 25. From B 1, 2, 3, 7, 12, 27. I am checking the age and weight. So what is the minimum weighted? Next we can select that 7, which is connected from B instead with the vertex B. So now you can select this. Okay. Now you can see from E what are the new edges incidents and with the minimum weight. Yes, this is the 10. This is the edge with minimum weight 10. So that is the edge EC. Next from B, that is, see now here it is not forming the cycle. Actually this is not the vertex. This is just intersecting the edges. This is the intersecting point of the edges. It is not the vertex. So it is not the cycle. It is not forming the cycle. So this is minimum spanning tree. Why we say minimum spanning tree? This is the tree with no cycles. And see, if you take any two vertices, you can find a path. That is the condition for minimum spanning tree. But here the weight is, total weight is 34. This is the minimum spanning tree. But when you write in the exam, you have to follow this procedure. You have to follow this procedure. Just I show here the final touch. Okay. Now this is the minimum weight of this minimum spanning tree. Say another example. Now you see here, use Prim's algorithm, determine a minimum spanning tree with minimum total weight. Now this is the given graph. You see, where is the minimum weighted edge? We have two, this one and this one. You take any one. For example, if I take this, okay, weight is 1. Okay, good. Now from this I have only one vertex, that is weighted 5. Here I have 1, 2, 3. This is the minimum weighted out of all these 4. 1, 2, 3, 4. So new edges, this edge, this is the minimum weighted edge. So I can select this. Similarly, do this procedure until getting the spanning tree with minimum weight. Here also you check. This is the tree, first one. Second, no cycle. Okay. Third one, if you take any two vertex, for example, you take this vertex and this vertex, yes, there is a path from here to here and here and here and here. So this is a spanning tree. Here if you add all the weights, that is minimum. The weight is minimum, that is 13. So this is called minimum spanning tree. This is the way how we find the minimum spanning tree with minimum weight. That's it. Thank you.